Hey, what's up everybody? Welcome to another Mathconnect tutorial. In this lesson, you'll be learning how to solve equations using what I call the three-box method. The requirements for this lesson are that you know how to add, subtract, multiply, and divide. So what is the three-box method? Let's take a look at an example. If we take a look at the simple equation x plus 5 equals 7, we can separate each element into boxes. We have x, we have plus 5, and we have 7. Now, the aim of solving an equation is to isolate the pronumeral, in this case, x. So to have x on its own, what we need to do is move the 5 over to the right-hand side. As you know, when you move elements from one side to the other side, you need to do the opposite operation. In this case, the plus 5 will become a minus 5. So the equation would now look like this. X equals 7 minus 5. And we know that 7 minus 5 is 2. Similarly, if we had x minus 5 equals 7, again, we give each element their own boxes. To have the x by itself on the left-hand side, we need to move the minus 5. And as you know, when you move each element, you do the opposite operation. So on the left-hand side, what remains is x. On the right-hand side, you have 7. And because you move the minus 5 over, the minus 5 becomes plus 5. So the answer is 7 plus 5, which is 12. So let's take a look at more complicated equations and how we use the three-box method to solve these. Let's take a look at this new equation, 2x plus 3 equals 13. The first step that we need to do is separate everything into its own boxes. Remember, there is only 3 boxes. So we know the first box is 2x. The second box is plus 3. And the third box is 13. At the moment, we can't separate the 2 and the x. So that's why they're in the same box together. So our only option is to move the plus 3. So when you move the plus 3 over, the left-hand side, you'd be left with 2x. You have 13 on the right-hand side. And because you've moved the plus 3 over, the plus 3 becomes a minus 3. So the equation will look like this. 2x is equal to, and 13 minus 3 is 10. So you're not finished yet. You still want the x by itself. Now, some students will look at this and they say, oh, sir, there's only going to be 2 boxes in this one. Well, if you look at it carefully, there is actually 3 boxes. You have 10, you have the x, and you have the number 2. So if you want the x by itself, your only option now is to get rid of the 2. You know that the 2 is a multiplication operation because it's 2x. It's 2 times x. So if you want to move the 2 over to the right-hand side, you need to do the opposite. And the opposite of multiplying by 2 would be divide by 2. So the left-hand side, you'd only have x left. The right-hand side, you have 10. And because you've moved a multiplication of 2 on the left-hand side to the right-hand side, the 2 becomes a division. So your final answer would be 10 divided by 2, which is 5. So how do we test to see whether the solution is correct? Well, Remember that equation has to be balanced. So that is, the left-hand side needs to be exactly the same as the right-hand side. So if we take a look at the left-hand side, it says 2x plus 3. We've just found that x equals 5. So we have 2 times 5 plus 3. We know that 2 times 5 is 10. And 10 plus 3 is 13. So therefore, the left-hand side equals the right-hand side. And that's how you know you've got the right solution. So let's take a look at this example. 3x minus 6 equals 9. We start off by putting our elements into boxes. There's a box for 9. There's a box for minus 6, which means the final box is 3x. So our first move is to move the 6. When we move the 6, we have 3x left over from the left-hand side. We have the 9 on the right-hand side. And we've just moved the negative 6 over. So the negative 6 becomes a positive 6. So 3x is equal to 9 plus 6, which is 15. So now let's break up our elements into boxes again. We have 15, we have x, and we have 3. Because we want the x by itself, we want to move the 3. And we know that because this is a multiplication, we need to do the opposite, which is division. So x becomes an element on its own. We have 15, and again, because it's a multiplication, we do the opposite when we bring the 3 over, and it becomes a division. So the answer is 15 divided by 3, which equals 5. And once again, we double check to make sure that our solution is correct. So the left-hand side says 3x minus 6. We know that the x is 5, so we do 3 multiplied by 5 minus 6. We know that 3 times 5 is 15, and 15 minus 6 is 9. Our solution is correct. So I hear you say, well, what if the equation is a lot more complicated? Well, let's take a look at this example. 2x plus 3 over 5 equals 7. Now, we can always use the 3-box method, guaranteed. So where would those 3 boxes be? Well, we know that there will be a box for 7. And because fractions, the left-hand side is a fraction, we know that a fraction is made up of the numerator and the denominator. So the denominator is one element, so we put that in a box, which means we only have one box left over. So the one box left over is for the rest of the numerator. As you can see, 3 boxes. So our first step is to what? That's right, we want to move the 5. So because the 5 is a division, when we move it over to the right-hand side, it becomes a multiply. So what's left over on the left-hand side is 2x plus 3. The right-hand side, you have a 7. And because, like I said, the 5 is a division on the left-hand side, when you move it to the right-hand side, it becomes a multiply. So what we have is 2x plus 3 equals 7 times 5 is 35. Again, we go back to our boxes. The first box is 35. The second box is 3. Therefore, the only box left over goes to 2x. So what's our next move? Well, we know that we can't separate the 2 and the x because they're together in one box. So that means our only option is to move the plus 3. So when you move plus 3 to the other side, it becomes a minus 3. So you have 2x left over on the left-hand side. You have 35, and you move the plus 3 over, it becomes a minus 3. So we have 2x is equal to 35 minus 3 is 32. We're still not done yet because the x is not by itself. It's connected to the 2. So let's see where our boxes are. Our first element is 32. The second box is 2. And the third box belongs to the x. So if we want x by itself, then we need to move the 2 over. Now, because the 2 is a multiplication, when we move it over to the left-hand side, it becomes a division. So we have 32 divided by 2. And the answer is 16. So let's double check to see if our solution is correct. The left-hand side is 2x plus 3 over 5. And we know that x is 16. So let's put that in. It'll be 2 times 16 plus 3 over 5. So 2 times 16 we know is 32 plus 3 over 5. 32 plus 3 is 35. And 35 divided by 5 is 7. So our left-hand side equals our right-hand side, which means our solution is correct. So as you can see, it doesn't really matter how complicated or complex the equation looks. You can always solve it using the 3-box method. To test this theory, whether the 3 boxes actually work on complicated equations, let's take a look at this equation. We have 2x minus 8 all squared divided by 4 is equal to 9. And we need to find out what x is. So the first step is to separate all the elements into 3 boxes. You have a box for 9. Now, you know that fractions have a numerator and a denominator. So the denominator will be 1 box and the numerator will have its own box. Now, as you can see with the numerator, there are many elements within that 1 box, so you know that you can't do anything with it. So you have to leave it alone, and your only other option now is to get rid of the 4. So you know that the 4 is a division, so to get rid of it, you need to do a multiplication. So when you do that, the left-hand side becomes 2x minus 8 squared is equal to 9 times 4. And you know that 9 times 4 is 36. So the equation looks like this. 2x minus 8 all squared is equal to 36. So let's see now how we can fit this new equation into the 3 boxes. Start off with this simple one. That's 1 box. You know that there's nothing you can do with the 2x minus 8 because it's inside brackets. So we give it its own box. And the last box, obviously, belongs to the square. Again, because the 2x minus 8 is within brackets, and all that is within its own box, there's nothing you can do about that. So the only option you have is to get rid of this square. Now, as you know, what's the opposite of squaring something? That's right, you square root. If you square root the left-hand side, what's left over is 2x minus 8. And you have to square root the right-hand side. So the square root of 36 is 6. So your equation now becomes 2x minus 8 is equal to 36. We're almost there. So let's look at our boxes again. We have a box for 36, we have a box for minus 8, and we have a box for 2x. Your next move would be to move the minus 8. So you have 2x is equal to 36 plus 8, and 36 plus 8 is 44. So we now have 2x is equal to 44. Again, we do our boxes. There's a box for 44, there's a box for the x, and there's a box for the 2. So we're on the final step now. We want the x by itself, which means we need to move the 2. And because the 2 is a multiply, we need to do the opposite, which will be divide. So x is equal to 44 divided by 2, and the answer is 22. So guys, as you can see, using the box method is a very, very useful way of helping you to solve equations. As with anything, the more you practice, the better you'll get. And this concludes our lesson. As always, if you enjoyed this lesson or found it helpful, please support the channel by subscribing and spreading the word.